Hello dear viewers. In business statistics, today we shall discuss about the graphical and diagrammatical representation of statistical data. In my last lecture, that is in lecture 4, we have discussed how a huge mass of data can be classified and summarized and to put in the form of statistical tables. These statistical tables are further available for statistical analysis. But if we use these statistical tables for the common man in exhibitions, or if it is used by the print media or televisions, then a common man will find it difficult to understand, he will find them dull. Therefore, one of the most convincing and appealing ways in which statistical results may be presented is through diagrams and graphs. There are numerous ways in which statistical data may be displayed pictorially, such as different types of diagrams, graphs and maps. Diagrams and graphs are extremely useful because of the following reasons. They give a bird's eye view of the entire data. They are attractive to the eye. They have a great memorizing effect. They facilitate comparison of data relating to different periods of time of different regions. Now, question arises, what is the difference between the graphs and diagrams? Generally, graph paper is used to construct a graph, whereas diagram is generally constructed on plain paper. Next, the graph are very much used by statistician or research worker in analysis, whereas diagrams are more attractive to the eye and as such are better suited for publicity and propaganda. Therefore, in the exhibitions and by the print media, the diagrams are used to present the statistical data. Also, for representing frequency distribution and time series, graphs are more appropriate than diagrams, whereas for frequency distribution, diagrams are rarely used. There are certain rules for constructing diagrams. The number one is the title. We should give a title to the graph or to the diagrams, which tells about the types of the data which we are presenting through graphs and the diagrams. Number 2 is the proportion between width and height of the diagram. Third, the selection of scales, that is what scale we take on the x axis and y axis. Fourth, the footnotes. Fifth, index. Sixth, neatness and cleanliness. And seventh, the simplicity. The simple bar diagram we draw mainly when our variable under study is discrete. The simple bar diagram is constructed by taking each bar of the same width and its length varies according to the data. For example, we are given here a statistical table which gives the information about the dividend paid in different years by Oswald Agro Mills Limited. The company paid in 2003 20% dividend, in the year 2004 they paid 30% dividend and so on. In the year 2008 they paid 50% dividend. Now, the question arises how we can show these data through the simple bar diagrams. We take the two axes on a plain paper and these two axes are perpendicular to each other. The horizontal one we call it the x axis and the perpendicular to it we call it the y axis. On the x axis we take the years and on the y axis we take the dividend. And here we can take a scale that 1 centimeter is equals to 10% dividend. This way we construct the bars against each year and the length of the bar is proportional to the dividend. And then on the top of each bar we place this data, that is 20, 30, 32, 42, 50 and 50. Now, if we just look at the diagram, then it gives me complete information about the statistical data present in the table. Now, we shall discuss subdivided bar diagram. The subdivided bar diagram is used when our variable under study is discrete and it has various components. As we see in this example, our variate under study is the assistance sanctioned in crores of rupees, and it has three components: the assistance sanctioned by the banks, SFCs, STDCs in different years. For example, in the financial year 1993-94, the banks sanctioned 233.8 crores of rupees, SFCs sanctioned 365.3 crores of rupees, whereas STDCs sanctioned 283.4 crores of rupees. And this type of information is given for the financial years 1994-95, 95-96, 96-97 and 97 and 98. Similar to the simple bar diagram, we take the two axes, x-axis and y-axis. On the x-axis, we take the year, and on the y-axis, we take the assistance sanctioned, and here we use a scale for the y-axis as 1 centimeter is equals to 500 crores of rupees. Then we draw the bars by taking the total amount sanctioned in that particular financial year. For example, in the financial year 1993-94, the total amount sanctioned was the sum of 233.8 plus 365.3 plus 283.4 crores of rupees. So, a bar is drawn against the year 1993-94, and the height of the bar is proportional to the total amount sanctioned in the financial year 1993-94. This is the first step. Then in the next step, we divide this bar diagram as per the amount sanctioned by different components, that is by bank, SFCs and STDCs. So, and the similar type of divided bars we draw for different years. So, when we look at this subdivided bar diagram, then we can have a comparative picture of the assistance sanctioned in different years by different organizations like the banks, SFCs and STDCs. Now, we shall discuss about the multiple bar diagram. The multiple diagram is also used when our variable under study is discrete in nature and it has different components. For this, either we can use the subdivided bar diagram or we can use the multiple bar diagram. It is our choice. Here, for example, we have the variable under study is the performance of the company in the forms of the sales, gross profit and the net profit, which are its three components. For example, in the year 2005, there was a sale of 120,000 crores of rupees, whereas the gross profit was of 40,000 crores of rupees and the net profit is of 20,000 crores of rupees. Similar type of information is given for the year 2006, 2007 and 2008. Now, we can draw the three different bars for the year 2005. All these bars are again of equal width and their height is proportional to the various components figure. For example, in the year 2005, the first component is the sale. So, the first bar will have the height proportional to the sale. The second bar will have the height in proportion to the gross profit and the third bar will have the height in proportion to the net profit. So, this is a set of three bars for the year 2005. So, the number of bars will depend on the number of components of the x variable. Then just leaving the gap, we draw the three graphs, such three graphs for the year 2006, 2007 and 2008. And for the clarity and to make them attractive, we draw the different shades and put the different colors so that it attracts the common man to look at these graphs and try to understand the information given in these graphs. Now, we shall discuss another important diagram that is known as the pie charts. The pie charts are in the form of the circle, and normally we come across to such type of diagrams in the exhibitions or in the print media, and they attract the attention of the common person. These pie charts are drawn to show the various values of a discrete variable. For example, here in this table we are provided the information regarding the funds which was sanctioned by a leading financial institution in different financial years. For example, in financial year 1988-89, the financial institution sanctioned an amount of 1444.3 crores, and in the year 1989-90 they sanctioned 1607 crores, and so on. In the financial year 1995-96 they sanctioned an amount of 5727.8 crores. Now, the question is how these data can be shown by using the pie chart. Now, we know that the angle at the center is 360 degree. So, our first step is to calculate the angle for each of the financial year. So, this angle of 360 degree is to be distributed over these financial years, and this is done by this formula where angle is equals to amount sanctioned in a year divided by the total amount sanctioned, and this is multiplied by 360 degree. For example, for the year 1988-89, the amount sanctioned in a year is 1444.3 crores, whereas the total amount sanctioned in all these years is 25,104.2 crores. So, this is divided by this, and then when we multiplied it by 360 degree, it gives me the figure presented in the last column, that is 20.71 degree. For the financial year 1989 and 90, this comes out to be 23.04 degree. For the next financial year, it is 27.32 degree, and so on. For the last financial year, that is the year 1995-96, we have the angle 82.13 degree. Now, once we calculate these angles, then with the help of a protractor, we draw these angles at the center, and then to show the figures of the different financial years, we make use of the colors and shades to make the graph more attractive and make the differences of the amount sanctioned in different years. Now, we shall discuss the graphical presentation of statistical data, and the simplest graph is the line graph. And as I mentioned earlier, that for the graphical presentation we require a graph paper. Now, how a line graph is drawn, that we shall make it clear by using an example. Here we are given an example of the Bihar Sponge Iron Limited Company, and this figure gives about the amount of scrap they imported in different financial years. For example, in the year 1991-92, the company imported 1.5 million tons of scrap. In the financial year 1992-93, the company imported 2.5 million tons of scrap, and so on. In the financial year 95-96, the company imported 3.3 million tons of scrap. Now, how these data can be presented through the line graph? Now, here again on the x axis we can take the year, and on the y axis we take the amount that was imported. Now, on the y we take a scale that the 10 squares of the graph paper is equal to 0.5 million tons, and on the x axis we take the year at equal interval. Then we plot the points as per the observations for different years. For example, for the year 1991-92, the import was 1.5 million tons. So, we place a point against 1.5, and for the year 1992-93, we plot a point at 2.5 and so on. Once these points are plotted for different years, these points are joined by a straight line, and then we get this type of graph which is given here. Now, we shall discuss about the graphs of frequency distribution. The most popular and the most common graph is the histogram. The histograms are used for continuous type of data when our frequency distribution is of continuous in nature, as given in this example. Here we are given the different classes which shows the weekly wages. The weekly wages, for example, between 10 to 15, 15 to 20, 20 to 25 and so on between 40 to 45. So, here we have the continuous classes, and in the second column the frequencies are given of these classes. The histograms are drawn by plotting the bars or the rectangles, and for the histogram, width of each bar is equal to the magnitude of the class interval, and frequency of the class interval is represented by length of the bar. So, here we note that all the classes are of equal length. So, here on the x axis we take the weekly wages, and on the y axis we take the number of workers, and here we take the scale as 10 squares is equals to 5 workers, and then we draw the bars or the rectangles for each class, and the width of each of these rectangle is the same as the length of the classes are the same, but the height of these bars are proportional to the frequency of each class. So, this way we plot the histograms, and these histograms we can see give all the information available in this statistical table. But sometimes we may have the classes of unequal interval. For example, here when we have the weekly wages given in the first column, here the first class is of the length 5 because it runs from 110 to 115 rupees. The second class is from 115 to 120 rupees. The third class is also of the length 5. The fourth class is also of the length 5, but the next class 130 to 140 has the length 10, and again the next class has the length 20, and the last class, that is from 160 to 180, also has the length 20. So, here we have the classes of unequal length. So, how to construct the histograms for such case? To construct histogram for a frequency distribution having unequal class intervals, first we have to make all classes of same length. This can be done in following manner. Suppose equal intervals have the length h, then the classes of magnitude nh can be divided into equal classes of length h by distributing its frequency into all its subclasses equally. That is, frequency of subclasses will be f upon n for each, where f is the frequency of that class. For example, here our first 4 classes are of the equal length, and that is the length is 5. But when we come to the class ranging from 130 to 140, its length is 10. So, we divide this class in 2 subclasses. The first class will range from 130 to 135, and the next class will range from 135 to 140, and the frequency 12, it will be equally distributed to these subclasses, that is, the frequency of the subclass 135 to 40 will be 6, and also for the class 130 to 135 will also be 6. This way, for other classes also we divide the frequency into the subclasses and then draw the histograms as we done in the previous example. Then here we can see that the area of the rectangle is proportional to the frequency of the classes. The another popular graph is the frequency polygon, and the frequency polygon is simply drawn by joining the midpoints of each bar with a straight line in the histograms, as shown here in this figure, that we have joined the midpoints of each rectangle or each histogram with a straight line. So, this gives me the frequency polygon, and the frequency polygon can also be drawn by joining these midpoints by a smooth line. It gives us a smooth frequency curve for that frequency distribution. Now, lastly, we discuss about the ogive curves. Now, the ogive curves are drawn for the cumulative frequencies. When we have a continuous frequency distribution, then we know that the first column represents the class, the second column represents the frequency, and then we can have the cumulative frequencies of 2 different types, that is the less than and the more than type, as shown in this example. Here we have an example of the monthly profit given in thousands of rupees of 100 shops. For example, here there are 12 shops whose monthly profit ranges from 0 to 50,000 rupees. There are 18 shops whose profit ranges from 50 to 100,000 of rupees, and so on. Then we first prepare the cumulative frequency of less than type. We know that the first cumulative frequency will be equals to the first frequency, that is 12. Then the next cumulative frequency we get by adding the next frequency to the first frequency, that gives me 30, 57, 77, 94 and 100. Whereas the cumulative frequency more than type, we start with the total frequency, which is 100, and go on subtracting the frequency of the other classes one by one. This way we get the cumulative frequency more than, which are 100, 88, 70, 43, 23 and 6 for different classes. Now, here we plot first the cumulative frequencies less than type. The cumulative frequency less than type will be plotted against the upper limit of that class. For example, the upper limit of the first class is 50. So, first cumulative frequency 12 will be plotted against this by taking the number of shops on the y axis and the monthly profit on the x axis. But before that, we make a scale, that is, we can take the 10 squares is equals to 50,000 rupees profit, and on the y axis we take the 10 squares is equals to the 20 shops. Now, we first draw the curve for the cumulative frequency of less than type. We first put the points against the upper limit of each class, that is 50, 100, 150, 200, 250 and 300. Against each point we plot its cumulative frequency of less than type. So, against the 50 figure we have the 12 cumulative frequency, against 100 we have the 30 and so on. Then these points are joined by freehand. Similarly, we plot the cumulative frequencies of more than type, and these cumulative frequencies are plotted against the lower limit of the classes. So, therefore, our first class starts from 0 to 50, the lower limit is 0. So, against 0 we plot the cumulative frequency mentioned in this row, that is 100. And in case of the last class, the lower limit is 250 and its cumulative frequency is 6. So, against the 250 we plot a point and all these points are joined by a smooth hand. So, this gives me the two curves. To make a distinction between these two curves, we use different colored pencil and then show this graph, and we observe here one important aspect, that is the point where these two graphs cross each other. If we draw a perpendicular line on the x axis, then that value on the x axis will give me the median of the frequency distribution. Of course, it will be an approximate value of the median. The exact value of the median we calculate by using some formula that we shall discuss when we talk about the measures of central tendency. So, this way we can draw the ogive curves for less than and more than type of cumulative frequencies. And here we note one important point, that where these two ogive curves cross each other, and from that point if I draw a perpendicular line on the x axis, then that value on x axis gives me an approximate value of the median, which is one of the measures of central tendency, which we shall discuss in my forthcoming lecture. In this lecture, we have discussed diagrammatical and graphical presentation of statistical data. We have first discussed the diagrammatical presentation, and in diagrammatical presentation we have discussed the simple bar diagram, multiple bar diagram, the divided bar diagrams and the pie charts. Whereas, in the graphical presentation of the data, we discuss about the line graph, histograms, frequency polygon and the ogive curves. Thank you, viewers.